Hello and welcome to solving absolute value inequalities, day 2. Absolute value inequalities, and today we are doing day 2. So last Thursday when we met, we talked about when we just have inside the absolute value, we had numbers, and then we solved. Okay, and we always set up our two cases. So today what we're going to be concentrating is on this number on the outside. So remember, just like with the equalities, we have to move that number outside here first. We have to deal with this and then set up our two cases. So the first thing we're going to do is we're going to subtract 2 from both sides of this inequality system. So we have the absolute value of x. Don't flip because all we did was add or subtract. And 6 minus 2 is 4. Now we're going to set up our two cases. So the first one is just what it says without the absolute value. And the second case, when we do this, we're going to remember to flip our sign and put in a negative. So x is greater than or equal to negative 4. So over here on my number line that I've got, we can go ahead and graph this. So this first one, x is less than 4. So we at 4, that is going to be an open circle because it does not have the line underneath it. So it's an open circle, and it's any number is less than 4, and we get less than 4 by going to our left. Okay, and then we have x is greater than a negative 4. So on our number line, we go to negative 4. It's an open circle because, again, we don't have that line underneath. And it's saying any number greater than 4. And so it shades to the right. So our graphs are either going to be shading out or shading between. And so this one is going to be a shading between. All right, next sample problem here. So in this case, it looks like we have a negative 5 on the outside. So we're going to add 5, add 5. So we have the absolute value of x is less than or equal to, and negative 4 plus 5 is a 1. So now our two cases are going to be x is less than or equal to 1, and then we have x. Remember, in the second case, we're going to flip the sign, and we're going to make it equal to negative 1. So when we graph these, looks like I have a negative 1 closed circle because it has this line underneath it, and we're going to shade to the right. And in the other one, we have a closed circle at a positive 1, and it says any number is less than, so we're going to shade to the left, and then we shade between here. Okay, it's kind of like an and. When it's less than, it's kind of like an and problem that we were doing, and we shade between. All right, now in our next problem here, we still have a number that is on the outside of this absolute value. So before we do anything, we need to move this 2. Do not set up your cases until you move that 2. And because this says a negative 2, I'm going to add 2 to both sides. So I have the absolute value of x plus 4. Just leave your symbol because all we did was add, and 3 plus 2 is 5. Now it says absolute value, symbol number, so I can set up my two cases. X plus 4 less than or equal to 5. And then our second case, we're going to write x plus 4. And remember, we're going to flip my sign and make it a negative 5. So now we're going to solve this by subtracting 4 from both sides. So it looks like x is greater than or equal to negative 9. So on my number line here at negative 9, I have the line underneath it, which means equal to. So we are going to close this. Negative 9 is a solution, so we want to include it. And it's any number is greater than, so it goes to the right. Okay, now we're going to go solve this other one over here. So we've got to subtract 4. So we've got x, leave your symbol because all I did was subtract. 5 minus 4 is 1. So go back to your number line and add a 1 that's less than or equal to, which means we are going to color this line is. And it says any number is less than goes to the left. So we're going to shade between these two. Okay, when it's less than, remember that's like an and from our compound inequalities, and we shade between. Now we've got two questions over here. So one question says, is negative 10 a solution? Is negative 10 a solution? Is negative 10 part of the region that is shaded? So if I go put a negative 10 down here on the number line, is negative 10 shaded? No, not shaded, so therefore not a solution. Okay, then we have a second question over here, and they want to know, is negative 5 a solution? So if I go in here and I put negative 5 on my number line, is negative 5 part of that region that is shaded? Yes, it is. So yes, this is a solution. Another way you can do this if you don't have it graphed is to go back to your original problem. So when it says x plus 4 absolute value minus 2 greater than, less than, or equal to 3, let's plug in that number. In place of x, put in your negative 5. Negative 5 plus 4 is a negative 1, and the absolute value of negative 1 is 1. 1 minus 2. 1 minus 2 is a negative 1. Is negative 1 less than or equal to 3? Is negative 1 smaller than 3? And the answer is yes, so it is a solution. So you can answer these questions two ways, either by looking at your graph and seeing if it's in the shaded part, or by going back to the original problem and plugging it in. All right, let's try another one. Again, at the end, we're going to see if a couple things are solutions. So in order to set up our two cases, we want it to say absolute value, but I want to get rid of that 3 first. So I'm going to divide both sides by 3. So I have the absolute value of x is greater than 6. Now I divided by a positive number, so there's no flipping. So x is greater than 6. And then another possibility is going to be x. Now remember, when you write your second case, flip your sign and make it negative 6. So on my number line, I have the number 6. It's an open circle. We do not have a line underneath it, so we have an open circle. And then we are going to shade to the right. In the second one, x is less than negative 6, so I'm going to put negative 6 on my number line. It's an open circle because we do not have that line underneath it, so we're not including negative 6. And it says any number is less than, so I'm going to shade to the left. All right, let's go up and answer these two questions now. So the first question here in blue is 3 a solution? So when I put the number here, 3, is that part shaded? Is the 3 shaded? Not shaded, so not a solution. Not a solution. All right, now let's go try the green one. And the green one wants us to check and see if negative 7 is an answer. So if we go put negative 7 on the number line, and is that in the shaded region? Well, we go this way. So from this number, is that shaded? And yes, this is a solution. Okay, again, you can go back to the beginning and put in a negative 7 here. So what is the absolute value of negative 7? It is a positive 7. So now 3 times a positive 7, is that greater than 18? Well, is 21 bigger than 18? And yes, it is, so that's why we said yes. Whereas when we go in and we put that 3 in here, 3 times 3 is 9, and is 9 bigger than 18? No, that's why it's not a solution. So you can either do it by the graph or by plugging it in. Okay, last problem here. So looks like we have to move this 12 first before we do anything else. So we have the absolute value of 2x greater than or equal to 6. So I'm going to set up my two cases. 2x is greater than or equal to 6. And the second case is going to be 2x is, remember we flip it, less than or equal to negative 6. So we're going to divide both sides by 2. So x is greater than or equal to 3. So I'm going to go to my number line here. Greater than or equal to, which means we're going to have a solid, and we're going to go bigger. Greater than or equal to is to the right. Now on the second one, when we divide by 2, we have x is less than or equal to negative 3. Closed circle, and it says any number less than. So less than goes this way. All right, they want to know, is 0 a solution? So is this number 0 right here in the shaded part? No, so this is not a solution. All right, now let's try the green one. So 75. If we were to put 75 on this number line, is it going to get shaded up here where that 75 is eventually? Yep, so this is a solution. Okay, so you can check it from the graph, or if you want, go ahead and plug it in. All right, the big thing for today is making sure that you get rid of this number before you set up your two cases. So your assignment is in your Schoology. It's on that homework or a quiz kind of thing, and it's absolute values, and it's day 2 homework.